Gibbs free energy, JessicaJang. Learning objective. The student is able to determine whether a chemical or physical process is thermodynamically favorable by calculating the change in standard Gibbs free energy. We'll apply science practice 6. The student can work with scientific explanations and theories. Delta G shows us the amount of work yielded from a process at constant pressure and temperature. We use the equation delta G equals delta H minus T delta S, where delta G equals free energy change, delta H equals enthalpy change, T equals temperature, and delta S equals entropy change. Entropy means disordinates in a system, and enthalpy equals energy gained or lost in a system. We'll use Big Idea 5. The laws of thermodynamics describe the essential role of energy and explain and predict the direction of changes in matter. If delta G equals 0, the process is at equilibrium. If delta G is greater than 0, the process is non-spontaneous, and if delta G is less than 0, the process is spontaneous. Exothermic processes release energy and endothermic processes absorb energy. Spontaneous processes occur without external forces, and these are thermodynamically favorable. We use science practice 1. The student can use representations and models to communicate scientific phenomena and solve scientific problems. As heat is being released, the molecules begin to move and shake around. Eventually, the bonds between the molecules break and molecules become more free, and entropy or disorder increases. Since heat leaves the system, delta H is less than 0 and delta S is greater than 0. In the Gibbs free energy equation, we would do a negative number minus temperature times a positive number. Since a negative number minus a positive number is negative, delta G is less than 0 and the reaction is spontaneous. This is thermodynamically favorable. Next, we see two molecules merge together with the application of heat into the system. However, imagine that there is little heat and the temperature is low. The molecules aren't able to build bonds together and actually move apart from each other due to the lack of high temperature. This movement can be described by delta H is greater than 0 and delta H is greater than 0. Using the equation, low temperature times a number equals a small positive number. A positive number minus a small positive number yields a positive delta G, a non-spontaneous reaction that is thermodynamically unfavorable. With high temperature, a positive number is being subtracted by a bigger positive number, resulting in a negative delta G, a spontaneous reaction, and this would be thermodynamically favorable. In the next scene, two molecules come together as heat is entering the system. In the equation, we would do positive delta H minus temperature times a negative number. Positive number minus a negative number makes addition of positive numbers, and delta G would be greater than 0, so the reaction is non-spontaneous, and this is thermodynamically unfavorable. This chart below summarizes this information accurately. We also use science practice 2. The student can use mathematics appropriately. In this practice problem, we are given delta H and delta S relative to a reaction. To find the standard free energy change at 298 K, we can use the equation delta G equals delta H minus T delta S. Substituting for the values we already know from the given equation, we get that delta G equals negative 173,669.6 kilojoules per mole, and we can say that this reaction is spontaneous since delta G is less than 0, and this is thermodynamically favorable.